Now we're going to learn a new topic. It's called partial fractions. You might wonder, what is this? Actually, this is very important if you're going to learn calculus. So that is why they put this in this pre-calculus class. Okay, so the partial fraction is one of the application, or how to get that is one of the application of what we just learned from system of linear equations in 2 or 3 variables. So what does that mean? Okay, so let me give you one example and I will explain this to you. And what is a partial fraction? What does that mean? Okay, what it means. So if I give you 3 over x minus 4 minus 2 over x plus 2. Okay, I give you this minus that. Can you combine them and write that as a one rational form to show me? Well, yes. So we know we have to find the least common denominator, right? LCD. And for this x minus 4 and x plus 2, the LCD will be just the product of x minus 4 times x plus 2. Okay, so we're going to change both thing into x minus 4, x plus 2 in the denominator. Then what happened to the numerator is you get to see what you're doing to the denominator. You have to do the same thing to the numerator. Well, what you're doing is you multiply by x plus 2, so you have to do the same thing. X minus 2 is a plus, x plus 2. Okay, and this part comes from here, x plus 2, you multiplied by x minus 4, so you have to do that, x minus 4. Now the good thing about this is one, kind of like a fraction or rational form minus another rational form, they have the same denominator. So we keep the same denominator, x minus 4 times x plus 2, and then we're going to simplify the numerator. We distribute this to 3, so we have 3x plus 6. And here is a 2x minus, so it's minus 2x, and then negative 2, negative 4, so that's plus 8. Okay, so then we're going to do just one more step. I have the denominator x minus 4 times x plus 2, and the numerator I have a 3x minus 2x, which is x, and a 6 and 8, which is a 14. Okay. Even further, if I give you the numerator is x over 14, the denominator, I use a FOIL method, I multiply this out, I get an x squared minus 2x minus 8. Okay, so now you look at the way you're doing it. You have a 2 simple fraction form, and then you combine, because one, it's like a one fraction minus another one, and then you combine them and then you get a one like a rational or fraction form expression. So from here to here we have no problem because we learned this, right? But this, in this section or in this class, I'm going to show you how to go from here back to here. Why we need to do that? Because later you're going to figure out this will help you a lot to break that into smaller pieces. So when you do the integration, when you learn calculus, it will be much easier. So if you plan to take a calculus after this pre-calculus class, this is like the must know, okay? And today I'm going to teach you how to do this, and I'm going to teach you 3 rules, and then give you some exercise, and then you're ready to go. Okay, now rule number 1. You might want to take a note. Okay, AI and BI are distinct, which means everything is different, right? Distinct. Okay, so watch. I have a P of x on top, and the denominator I have a1x plus b1, a2x plus b2, and then multiply by the last one, sorry, an x plus bn. So at the bottom I have several linear terms multiplied together, and the top is a p of x. Then that's why I said this ai, bi are distinct, which means each of them are different. There's no square thing, okay? So everyone is different. Compare with this one. Do you see this? Here is x minus 4, x plus 2. They're different. Then, which means in the denominator, you have all those like linear expressions, and they're all different. If that's the case, then this one you can express it as a1x plus a b1 of a number plus a 2x plus b2 plus, and then all the way to the last one, a nx plus b, and here's plus. So there's going to be several terms in between. And that's what it says. So if you have something look like this, the numerator, there's a polynomial fraction or whatever, it has that. And then down here you have the product of several linear expressions. Then there is a way you can transfer, or you can make it back to this form. See, here is a 3, here's a 2. So here, this A1, capital A1, A2, and all the way to AN, they are numbers. What does that mean? Okay, which means, let's just work backwards, okay? So if I give you x plus 14 over x squared minus 2x minus 8, okay, can you find the partial fraction decomposition? Kind of like we break that down. So decomposition. All right, now if you want to do that, we write at the top x plus 14, and then the denominator here is quadratic form, so we can factor that, right? So when we factor, you get x minus 4 times x plus 2. This is exactly, looks exactly like we just mentioned in the rule number 1. Then, which means I can have A1, or I just call that A because I use different letters, might be easier, over x minus 4 plus another one, B, over x plus 2. By rule number 1, I know I can write this into this. It's called called a partial fraction decomposition. Partial fraction decomposition. Okay. Now, my next step is to find A and B. How should I do that? It is funny because once you break that into this form, and then we have to keep this A and B, and we do it backwards. We back to the, just like we did from here to here. Okay? So find the least common denominator, which is x minus 4 times x plus 2. And then this one is going to be a times x plus 2. And then here, that's going to be b times x minus 4. So I have x minus 4 times x plus 2. Looks familiar, huh? And then I go, the denominator will be x minus 4 times x plus 2. And the numerator, let me distribute this a, so I get ax plus 2a. Agree? And then here will be plus bx minus 4b. All right. Now, one more step. I keep the denominator x minus 4, x plus 2. Now, let's see the x term. We have ax plus bx, so we have a plus bx. And the number part, or the part without x, that's going to be 2a minus 4b. Okay, so now you see, by the rule, we break this into this, and then we combine them back together, because when we bring them back together, we keep the a and the b there, and then we're going to compare this too. Compare this with that. What do you see? Here's a plus bx, here's just 1x. Here's a 2a minus a 4b, that's a number, and here's a 14. You get the idea? So we have a plus b equals 1, and we have 2a minus a 4b equals 14. What do you get? You get a system of linear equations. All right. So once you have this, then you can just go ahead and solve it. You get a plus b equals 1, 2a minus 4 equals 14. Would you like to use the substitution method or you want to use the elimination method? I always like to use elimination method because here's a negative 4. If I can make this a 4, then b will be gone. So I use this one multiplied by 4. I get a 4a plus a 4b equals a 4. And then here I get a 2a minus a 4b equals a 14. I add them up. I get a 6a equals 18. Therefore, my a is 3. And a plus b is 1. When a is 3, b must be negative 4. This is so beautiful because I got an a, I got a b. I can just put it back to here. A is 3, b is 4. So what you are given here will becomes 3 over x minus 4. Plus, here's a negative 4, so we can say minus 4 over x plus 2. Let me write that. So I have x plus 14, the original question, minus 2x minus 8 equals 3 over x minus 4 minus 4 over x plus 2. That is my answer. You're done with it. Okay, so now you compare this with the one that were given at the very, very beginning. A. I did something wrong. Sorry, negative 2. I know I make mistake all the time. Okay, so so you see that we learned how to get from here to here. That's what we know a while ago. Now we know how to break this back from here to here. We are doing the partial fraction decomposition. Okay, so that is the rule number 1. If your denominator has all those linear terms and each one are different, then you're going to be able to break that into this form. So you break that into this form and just call them. You can call this A, B. You can call this as M, N. You can call this as A1, A2. It doesn't matter because the purpose is to find them, to find what the number is that. Okay, so that is the rule number 1. Not too bad, right? You want to try one more? 5x minus 1 over, here's x minus 3 and x plus 4. You can put a pause on this video and then start trying this by yourself. And I'm going to do this right now. And when you finish, you can come back and check with my answer. So let me just do it. If you don't want to pause, that's okay. So I get a over x minus 3 plus b over x plus 4. How do I get that? By rule number 1. And then my next step is, I just a little lazy, so I just write x minus 3 times x plus 4 already, because I know it's going to be the least common denominator. And the numerator is going to be a times x plus 4 plus b times x minus 3. Okay, and then the denominator again is x minus 3 times x plus 4. And here it's going to be ax plus bx. I write ax. Oh, okay. Let me do that step by step. Okay, so plus bx minus 3b. What I'm doing is I get rid of this parenthesis by distributing a and b into the parenthesis. And then my next step, I'm going to combine x minus 3x plus 4. My next step is I'm going to combine the x terms, so I have a plus bx. That's how many x I have. And for the number without x, I have 4a minus 3b. All right, now I would compare this with my original given expression. Then I get a plus b equals 5, and I get a 4a minus 3b equals negative 1. Not bad, huh? And then I need to solve for a and b, and I use this, the first one multiplied by 3, because I want to get rid of this negative, I want to get rid of b. So I have a 3a plus a 3b equals 15, and a 4a minus a 3b equals negative 1. Okay, and then I add them up. I get a 7a, this is gone, equals 14. So luckily, I get a equals 2. And a plus b is 5. When a is 2, my b should be 3. Okay, so what you can do is, oops. So a is 2, b is 3. So your answer will be 2, 3. If you write the answer like this, 5x minus 1 over this guy, it becomes a 2 over x minus 3 plus 3 over x plus 4, then you're good. You already get the answer. Okay, so you can check with your answer to see whether you get the same thing with me. Again, if you don't trust yourself, then you can just go ahead and perform this again to see whether you can get the left side. Okay, so that is the rule number 1. Okay, we're going to do rule number 2. Different rule will be applied to different situation. Okay, so what is the rule number 2? Rule number 2 is, if you have a numerator here, I don't know, and the denominator you have ax plus b to nth power. That would be, you can break that into a1 times ax plus b and a2 with ax plus b square and all the way to another one is, a n, and here is ax plus b to the nth. Okay, so here a1 all the way to an, they're numbers, there's no x involved, which means if you have something like with nth power, so you can break that into this and this, first degree, second degree, and all the way to nth degree. But the numerator, you don't really have a polynomial with x, you have all the numbers. Okay, sounds good. All right, now I'm gonna give you a question. I will ask you to find the partial fraction decomposition of this. X minus 18 over x times x minus 3 square. So when you do this, you say, hey, wait a second. How come here you only give the ax plus b to the nth power? Here you get an x there. Yep. And do you remember our rule number 1? If you have something like this, then you have a number over that. This is a 1x plus 0. If you think that way, then that'll be easier, right? So I will say this. This one, I can break that into a over x. And then here, do you remember for the rule number 1, I said here they are all distinct, which means they're all different. But this one, I have x minus 3 and x minus 3. So I will have, based on the rule number 1 and number 2. So I have this, and I have a square term. Okay. All right. So from this guy goes here, that's from the rule number 1. And then later, this is the rule number 2. Once I have this, let me just go backwards. I find the least common denominator is x times x minus 3 square, which is the same as this denominator, right? Okay, so then this a, I got to multiply by x minus 3 square. So that will be a times x minus 3 square. And the middle term, b, because I have an x minus 3. If I want to bring this into this LCD, I have to multiply by x and another x minus 3. Okay, and the last one, x minus 3 squared, I only need a cx. All right, okay, now let's keep going. I have the denominator x minus 3 squared. Now what is x minus 3 squared? So that is a times x minus 3. You can use a FOIL method, or you can use the formula. That's x minus 6x plus 9, and then plus, and then we distribute this b, so that's bx squared minus 3bx, and then plus cx x. Okay, and then I'm going to continue. If I continue, I will get the denominator. I think I might not need to write it, but okay, just to be perfect, I write it. So then I distribute a inside the ax squared minus 6ax plus 9a, and then I go ahead and plus bx squared minus 3bx plus cx. It's very complicated. All right, now I'm going to put x minus 3 squared. Now I will combine like terms. So for the x squared term, I have a plus b x squared. Now the next one is I need to get the x terms. One x, another x, another x. So I have negative 6a and negative 3b and then plus c, that many x. Okay, and then for the pure number without x part, I have a plus 9a. I will compare this numerator with this, x minus 18. So that got to be x minus 18. Then what do I know? I know this. I know a plus b is 0. And I know negative 6a, negative 3b plus c equals 1. And also I know 9a equals negative 18. Again, I get this system of equations. And it's not bad to solve it because, see, 9a equals negative 18. My a should be negative 2. And a plus b is a 0, so my b should be 2. All right, now I have a negative 2 and 2. I plug in here. Negative 6 times negative 2, so I have 12. And this is 3 by 2, so 12 minus 6, that's a 6. And a 6 plus a c equals 1, so my c is negative 5. All right, then since you know ABC, you can just put in here. I just use my little red pencil to write negative 2, and my b is 2, and this is negative 5. Okay, so I did it. And of course, if you like, you can write that in a nice, neat form, but I don't do it. All right, now this is the rule number 1, rule number 2, and the last rule, rule number 3. Rule number 3, okay, is this. If that is, the denominator looks like this. ax squared plus bx plus c. If this thing cannot be factored, you know sometimes you have this quadratic form that cannot be factored, then the partial fraction decomposition must contain a term looks like this, ax plus b. The difference with the previous rule, rule number 1 and 2, here the numerator you have an x term. All right, so I'm going to work on the last example. We're going to do this pretty quick and it's going to be easy. All right, so I'm going to do this, the example. 3x squared plus 17x plus 14 divided by x minus 2 and x squared plus 2x plus 4. So I would ask you to find the partial fraction decomposition of this guy. Now, by the rule, okay, because I have a top and I have a denominator, I have this and this. So I'm going to have a number a over x minus 2. And then I have this guy. This guy it's not a square. It's not like the rule number 2. Rule number 2 is ax plus b to the nth power. In this case, it's not. It's not a complete square or cube. It's not complete a square. And also, we cannot factor this. That means I keep this denominator here, but the top I have a linear term. That's what it says. Okay, and then of course my next job is to find b and c. So let's do that. And I work the denominator x minus 2 times x squared plus 2x plus 4. And then the numerator of the first term becomes this guy times that. So this a multiplied by that. So I have a x squared plus 2x plus 4. And then the second term is a bx plus c multiplied by x minus 2. Okay. And then I'm going to continue equal to the denominator. If I'm lazy, if you're lazy, you don't need to write it because you just know it's going to be the same thing. And then I'm going to distribute this ax squared plus 2ax plus 4a. And then this, I'm going to use the FOIL method. So that's a plus bx squared outer. So that's minus 2bx inner. So that's cx. And the last is minus 2c. So what I'm going to compare this is with this guy, with this. Okay? So let's see. I gotta combine. So a plus b, that's my square term. Okay. What about the x term? X term, I have a 2a minus 2b plus c, that many x. And the last one is a constant term. I have a 4a minus 2c. Again, I could keep saying that to be lazy, you don't need to write it, but I don't know. I'm not lazy, so I always write it. All right, now you compare this with the original given information. So what you have is a plus b is 3. 2a minus 2b plus c is 17. And then 4a minus 2c equals 14. All right, so you get this system of equation, right? So you're gonna solve it, and I think if you like, you can just get rid of c from here because you already have no c. So this one I multiply by 2. I get a 4a minus a 4b plus 2c is a 34, and then the bottom is a 4a minus 2c is a 14. So I add them up. I get a 8a minus a 4b equals 48. And then of course I will divide it by 4. So I get a 2a minus b is 12. And here I have a plus b is 3. I add them up. I get a 3a equals 15. Very good. I get a equals 5. And a plus b is 3. So my b got to be negative 2. And the 4a minus 2c is 14. 4a is 20. 20 minus 6 is 14. So my c should be 3 because 2, 3 is 6. And then I got a, b, c, which means bring that to the top. Okay, I got a 5 and negative 2 and a positive 3. So I got a 5, negative 2, and a 3. See? So that's going to be 5 over x minus 2, and the numerator is negative 2x plus a 3. And that's it. So I think that's all for this class.